Hello, I'm Georgios Sylaios from Democratic University of Thrace in Greece. This is a joint presentation, joint work with my PhD students, Dimitris, Alexandros, and my colleague from the Department of Electrical Engineering, Avi Arabadzis. And the title is whether it's possible to turn Twitter into an environmental citizen science data pool. So we all know that social media is potentially a data pool. The question is whether we can use them for environmental, for environmental analysis. We know that social media generate through the users big data, and there are several, in the literature, several big data analytical techniques which we can apply in order to understand what is within the data, what is hidden in the data, like trends or patterns and perceptions. So we use Twitter posts in order to understand the issues which are related to the perceptions of people. But in order to do that, we had to understand firstly the gender, the location, identify the location of each user, the topics which are discussed, and then based on that, we focused on the stance against a certain topic that we analyzed, the sentiment, and the aggressiveness level. So I will speak a bit about all those. We created the biggest worldwide Twitter dataset on climate change. And we published this in the Elsevier journal, Expert Systems with Applications, in 2022. And there is another publication that we recently completed in PLOS ONE. So this is the biggest dataset in terms of Twitter posts which refer to climate change. It contains 15 million tweets from 2006 until 2019 in English language only. But it's a global, so all the users of the world are members of this, have participated and have contributed to this dataset. For each tweet, we extracted the geolocation of the user, the identity of the user, of course, based on which we were able to understand the gender of the user, because this is what we are interested in, the deviation of temperature from the mean local temperature over the years, and the stance and the sentiment and the aggressiveness level in terms of the climate change and global warming. So there is a dataset. It is, you may find it through a link in this particular publication. This is the analysis we followed in a diagram. So initially we built a conceptual diagram, how we will analyze the data. Now you see that we have on the upper side of this slide, you see the timing of the different posts, and we were able to retrieve all this from 3 different sources. So we have one data source is an existing climate change dataset, which contained 14.3 million tweets. Then there was another climate change dataset that we merged with the IDs. And then we have our own Twitter dataset, which also contained archived data. We used a methodology which is called hydrator. Hydration is a process by which you link the IDs of each person with the contents of the tweets. And then we filter this with certain keywords. I will explain later. We remove the duplicates to clean the dataset, we merge everything, and we finally were able to identify the location of each person when he was tweeting, the gender, as I said, using a machine learning technique which identifies through a database the names and the gender based on these names. And then we added everything in order to create the dataset and to understand the stance against climate change, the analysis of the sediments, and the aggressiveness level, and of course we added the data like the deviation of temperature and the topics which are discussed. So this is in a slide what we did as a pre-processing, the data hydration, which is the process by which we link the user's ID with the content. Then the filtering, we use hashtag only keywords to which were relevant to climate change and global warming. Then the geolocation, we used the user geolocation when was given by the users. Most of the times users don't provide geolocation. Then we went to the Twitter the metadata and we found the location through there. There is a process you can find it. Then we link the geolocation with the geonames in order to be able to identify the gender. We use the machine learning algorithm to identify the gender based on names. The stance was produced through a classifier, a machine learning classifier, which categorizes the tweets in three categories: the believers, the deniers, and the neutral. When you stand, you have a neutral stance against global warming. Then the sediment is a number which ranges from -1 to +1, and it gives you the approach you have against climate change. So if you are ranked in +1, means that you are fully appreciate climate change as a human-produced impact. While if you are in -1, you are really highly denier of climate change. And the aggressiveness, whether your language is offensive or non-offensive, this is again something we can assess through this analysis. And this is a sample of the data we have. So you can see, for example, here on the left-hand side when the tweet was created, and the ID, you see that there is a number per user, then the longitude and latitude, the exact coordinates, the topic that was discussed, the sediment, as I told you, which varies between -1 and +1, the stance, if it's categorized as believer, denier, or neutral, the gender, the temperature deviation of that particular day, in that particular time, as a deviation of the mean 30 years temperature of that exact location, and whether it's offensive or not. So also we analyzed which are the resources on which users make comments on. So in Twitter there are information coming from various websites, and you see here that most of the users are making comments on articles produced by The Guardian or Washington Post or the New York Times or the BBC and the CNN, the highly ranked domains which provide posts on climate change. These are some of the keywords which are discussed by the users according to the topics. For example, when, as you can see, we categorize them in terms of, for example, the gas emissions. They discuss with all languages, and this is a process called text mining, as I told you. And we find which are the main words and phrases which are used in the text of users. Then this is a map of the location of the various users. So as you can see, most of them are located in the US and in Europe, in India, in the Western Australia, and so we don't have tweets from China or Russia or Canada, very few. This is a diagram, a set of diagrams which show the behavior of people when they are tweeting. So you can see that most of the tweets came in 2018, and there was a reduction in 2019. Then which are the months that people tweet mostly about climate change? You see that they tweet mostly in December and then in May. Which days of the week they tweet mostly about climate change? So the working days mostly, because they are in the middle of their work, perhaps in an unhappy environment, and they don't tweet much in the weekend because they have other things to do. And what is exactly the time they tweet about climate change? So you see that at 3 o'clock or 4 o'clock local time, they prefer to tweet about climate change, which is something very interesting because it coincides with the time that we have the highest, the peak temperature on a daily, in the summer on a daily basis. These are some examples of tweets as a text which were given, the topics, the sediment scores, the stance, the aggressiveness level, and the deviation of temperature. So you can find here some top words and phrases by the believers in climate change, which are not used by the deniers, and then some other phrases which are mostly used by the deniers. You can, in phrases, there is what is called unigrams or bigrams. If you use a lot words and phrases, words is unigram and phrases is bigrams. Climate change believers are about 10 times more than deniers. So we have 71% of believers than versus 7.5% of deniers, while 20.95 were considered as neutral. In climate change, the female believers were by 3% higher than the male. And also the deniers were 3% lower, female Twitter users than the males. Also, female believers are more sensitive to extreme weather events. In terms of aggressiveness, believers on average have a score of 0.27, which is a rather low score, while deniers have a score of, I don't know, it's 0.45, I think, so neutral users. So when deniers tweet, they are more aggressive. The deniers are more present in Canada, in the US, in Cuba, in South Africa, in Japan, in Eastern China, Australia, and Brazil. Europe, India, and Central Africa have the lower denier to believers ratio because we also calculated this deniers to believer ratio on a grid cell of 0.5 by 0.5 degrees. So this is the grid cell, and as you can see, with the red colors, we have the highest deniers to believer ratio, while with the blue colors, you have the lowest. This is, again, a diagram which shows the trends and patterns. And if someone wants to see the temporal change in the deniers to believer ratio, you see it over here with, I cannot move, okay. So it's the average historic temperature deviation, as I told you, from the 30 years mean versus the deniers to believers ratio over time. So you can see that after 2018, there is, there is a gradual trend in temperature, and this means that the deniers to believers ratio, which is with the red line, decreases significantly. There is a correlation of minus 0.53, which means that whenever we have a higher temperature, there is a tendency of deniers to reduce against believers. Again, here we have used a histogram where we have the bins of deviation of temperature, and we have with the blue line, we have the ratio deniers to believers. So we have, when we are very cold conditions, from the mean temperature, the deviation is very high, but minus, then deniers are higher, the deniers to believers ratio is high. When we are in normal conditions or when we move towards the very hot conditions, warm conditions, then deniers to believers ratio reduces. So people tend to associate climate change with the very warm conditions and not with abnormally cold conditions. This is another finding of this research. This is the number of tweets on one hand side, and the other is the mean sediment, again, in relation to the deviation from average temperature. As you can see, when temperature is colder, the historical average. From the historical average, people tweet negatively about climate change, while when temperatures are warmer, people tweet positively about climate change, despite the fact that rising temperatures are an effect of climate change. This was the main conclusion from this analysis. Why we are doing this? This comes from another project which is called Iliad, and it shows that we are testing the algorithm to see whether we are able to understand the perceptions and the sentiments of people, and whether we are able to use the Twitter as a means for triggering numerical models. This is something very novel, because we have the numerical models. In the middle of this slide, you see the OTTERS package, which is a suite of models that we use in oceanography. We have hydrodynamic models, we have wave models, we have water quality models, we have oil spill models that you see on the right-hand side over there, but we don't know when we have an oil spill. This is the problem. When, where is the oil spill? So when should we trigger these models? So we have on the left-hand side a series of processes, and we develop algorithms that will run on a daily basis to do the following, as I will explain. So to scan the satellite images, whether there is an oil spill. But in parallel, the satellite crosses an area every 5 days. So there is a gap of 4 days that we don't have a satellite above a certain area. So we need really to fill this gap. So the question is whether Twitter posts can be used for extreme events identification. For example, we have, and this is what we are doing now, there was an oil spill event in Syria in August 2021. We are making a publication on this, we are preparing a paper. What happened is that we had an oil spill on the 21st of August. And the first model was run on the 25th of August 2021. So there was a 4 days gap. Why? Because they were looking for bathymetry, they were looking for currents, they were looking for the winds, they were looking for the satellites. The satellites were not passing, and all these problems. The question is whether we can, using social media and citizen science as a social media, include this in the analysis of operational oceanography. This is something, again, as I explained, really novel. So we want really to scan the social media posts and to be able to find the proper words for oil spills, for any extreme event, environmental extreme event, and track it and see where it's happening, where is this user, what is he saying, why. Can we go back to the satellites in that particular location and check whether there is an extreme event? The first publication in this field happened a few years ago, when the meteorologists were unable to track Hurricane Katrina. And there were people tweeting on the impact of Hurricane Katrina. So the first guy who initially did that, and this is how we start thinking about it, was someone who used Twitter to find the track of a hurricane. What we are trying to do, this is the conceptual framework. We scan the Twitter, but we also try, when we provide all this advice and reports to the authorities, and the authorities are alarmed and they are able to respond to the extreme event, whether people are also happy about it. So the lower box over there shows that we can use, again, citizen science, and of course we can use the social media like Twitter to assess the evaluation and evaluate the cleanup operations and whether people think that the authorities acted on time. So this is the concept we are using in Iliad, and by the end of the year, we think that all the pieces will be ready to become fully operational and functional. Conclusions: the social media could offer a data pool for environmental scientists. Twitter allows free access to tweets and could be extracted, analyzed in terms of geolocation and gender. Sentiment analysis could be applied on text mining results from Twitter posts. Stance, sentiment, aggressiveness could be rated to perceive public perceptions on the certain issue, and secondary data like mean temperature, temperature deviation, extreme events could be merged to the above dataset to give us a full picture about how people feel and the conditions people are in a certain location at a certain time. That's it. Thank you.